Example 4, find f of x at f double prime of x equals 48x minus 14. So now we have a second derivative. They want to go back to the first derivative and then back to the original function. So we have to do it in steps. You can't go directly from a second derivative to the function. You have to step it off to do this. So f double prime is a derivative. Officially there's a plus 0 also there, right? Okay. Minus 14, of course, is a constant, but that's a constant in the derivative. There's still that plus 0 that could have come from the derivative of a constant, so you have to account for that possibility. So if I go down to f prime of x, okay, and I want to do this in 2 steps every time. I anti-differentiate by the formula, then I simplify every term. That'll be the derivative. Then I'm going to anti-differentiate the derivative, and then I'm going to simplify every term. So that's kind of how you want to go through this. So if I anti-differentiate 48x, I'm going to get 48x to the second over 2. Because originally it's x to the first, right? The rule says to increase the power by 1, divide by the new power. Now negative 14, if you just take a look at negative 14, there is no x on it, but officially it's x to the 0 power. And if I use that rule, it's going to be negative 14x to the first over 1, right? The easier way of doing it is if you have a constant in your derivative, stick an x on it, or whatever the letter is in the problem. The last problem we would have stuck a theta on it. All right, so whatever the letter is, if you get a constant in your derivative, it just came from that constant times x in the original function. And then again, the antiderivative of 0 is the constant that we don't know about. Maybe it has it, maybe it doesn't. Again, that's the antiderivative by the formula. Then I want to simplify that by making each term as pretty as I possibly can. 48 divided by 2 is 24. Minus 14x and plus c are perfectly fine. Okay. They want me to find f of x. All I've found so far is f prime of x, so now I need to go on and find f of x. I need to do the antiderivative of these 3 terms plus the 0 that may or may not be there. So f of x then equals, all right, so the rule says I take the power, raise it by 1, divide by the new power. I take the power, raise it by 1, divide by the new power. C is a constant just like minus 14 was a constant, right? So it's going to be plus cx. And then we have to account for a constant there also, plus a different letter. I like to use D. You don't want to use C both times because that C and D don't have to be the same number. Maybe C is 5 and D is 6. So you have to account for the possibility they're different. And if it was a third derivative going to a first derivative, you're going to have a C and a D and an E. And if it was a fourth derivative, C, D, E, and F, and so on. I've never seen a fourth derivative, but if they did, C, D, E, F. All right? And again, that's the function. This and this can both be simplified, so then I just take each term and make them simpler. 24 over 3 is 8. 14 divided by 2 is 7. Plus cx plus d. And if I was anti-different, so again, let's say I was going one more step back, right? So let's say this was the third derivative and I had to go one more step. Cx squared over 2 plus dx plus c. So there's just, they're going to be created in that manner every time. You can't really make those any prettier, but they are what they are.